This video will cover section 1.4 functions. We're going to determine whether relations are between two variables are functions, and those two variables to start with will be using x and y, and we will use the function notation, which is f of x. You have seen this before. We're going to find domains of functions. That would be a very important topic. And of course, we will also be finding the range. And then we're going to use functions to model and solve some real life problems. So we'll do some applications. And at the end, we will work with the difference quotient. And might not be your favorite, but it's not impossible. So let's get started. So we have many everyday phenomena involving two quantities that could be related to each other by some sort of rule of correspondence. So the mathematical term to that is the relation. So for example, height could be related to, well, I will probably say it the other way. Your weight is related to your height most of the time. Or for example, height is related to your age. Or we could compare, for example, I can't really think of anything right now. Well, let's think about something simple, the cost function. So the cost to make a product, it depends on the cost per product, but also we could have another cost, which we will call the fixed cost. So there are several things that could be, just explained as a relation. And in mathematics, equations are what we use, like the ones we use in the previous section 1.3 with linear equations. So the equations and formulas often represent relations. For instance, we have an example here which is called the simple interest, and we denote that with the letter capital I. And the formula to calculate the simple interest is going to be the principal, which will be the money earned, the $1,000, and then times the time, and then times the rate. So the formula is PRG. So in this case, because the time is 1, we just see the 1,000 times R. And so in this case, we will have to know R. But if we look at this function here, and I'm sorry, I should still be referring at it as the equation, represents a special kind of relation that matches each item from one set with exactly one item. So here we have two keywords, matches, and with exactly one item from a different set. And there are several ways to represent relations. So I do like to show the mapping. So I'm going to just adjust my camera view. So in this case, if we consider the first set to be the based on this equation here, the domain, which is also the set of all the independent, the values of the independent variable. Typically, we see the x values, but for this problem, the independent quantity or variable will be the rate. So all r's. And the other set will be the range. And the range represents the set of the dependent values dependent. Oops, I didn't write it right. Okay, dependent. And so here will be the interest. So for example, in the rate, if the rate is 5%, which we'll say like 0.05 instead of using the percent symbol, and we have $1,000, then we might get certain number here. And for 1 year, so it will be the product of 1,000 times 0.05. So it will be $50. So if for 1 year we put $1,000 in the bank with a simple interest, and the interest is 5% or 0.05, then the money earned will be 50. R is the interest rate. Now, if we change the interest rate to 2%, then we will have $1,000 using this formula times 0.02, and that will give us $20. Now, if the interest was, let's say 10%, so we will say we have to convert to decimal from percent, so we divide by 100, and that means moving your decimal point 2 units. So like 10% is 0.10. So if we do that, 1,000 multiplied by R, like it says on the equation here, the interest earned will be $100. So that one is telling us, that example is telling us that for every interest value that we chose here from the domain, it is related to exactly one item from one element from the range. So we don't have two values coming out of 5% or 0.05. We have a unique or exactly one value. Now, for 0.02, we have only one value, which is 20. And similarly, for 0.10, we only have one value for interest, which is 100. So that right there is the perfect example of a function. And also keep in mind that we were using 1 year for the time. So that is a relation, of course, but it is more than a relation, is a function. So let's go into the definition of the function. So it says a function, and we will use, of course, f, but we will start using other letters because we don't have to only use f. So a function f from set A to set B is a relation that assigns to each element x in the set A. So again, set A contains the elements of x. And is assigned exactly to one element y in set B. So we could also see that set A is going to be the domain, and set B is the range. And actually that was next. Set A is the domain, contains the x's, and then set B is the range, and it contains all the y's. Now we have other words. The set of set A, the domain, is also considered the set of all inputs. And the range is also considered the set of all outputs. So going back to my diagram, my mapping here, remember we said, and let me write this better, this was the dependent variable, but we also consider here all the inputs and this is all the outputs. So it's important to get familiar with this vocabulary. And remember the example that we did, it was with the equation I equals P times R times T, and actually more specifically for us it was 1,000 R because T was equal to 1. So that was the example we did. So we had the instead of X we were using R, but that's okay, no problem with that. And instead of Y we were using capital I because that was the output. So most of the time we'll be using X and Y, but we're not just limited to those letters. I want you to know that. Okay, so the key words, the main words here is that they can only be related to one element, one and only one. So we're going to see some counter examples. So let's look at the one here. We have another example. In the first set, the square on the left is showing us the time of the day. So this is going to be the domain. And you already know it's going to be the set of all inputs. Well, you could see that here. So we have, and this is PM. So we have 1 p.m., 2 p.m., 1 p.m., 2 p.m., 3 p.m., 4 p.m., 5 p.m., and 6 p.m. Now, our range, which is the set of all outputs, it contains the temperature in Celsius, degrees Celsius. So this is the range. I know we already have it. And also we could say, since we already have domain and range, let's add the other words that we're missing. We have inputs, we have domain. So this is the set, the time of the day is actually the independent variable. And the temperature is going to be the dependent variable. So I want you to get used to those words as well. And it is because the temperature depends on the time of the day. And so let's see the temperatures now. So we have that at 1 p.m. the temperature is 9 degrees Celsius. At 2 p.m. the temperature is 13. At 4 p.m. the temperature is 15. And at 3 p.m. the temperature is also 15. At 5 p.m. it's 12. And at 6 it is 10. And so if we look at the set of order pairs, so we have 1 going to 9. So we will have the order pair 1, 9. Then we have 2 going to 13. So 2, 13. And we have 4 going to 15. Then we have 3 also going to 15. And then we have 5 going to 12. And finally, we get 6 going to 10. So those are the set of order pairs, and we also have them here. So also, if we're calling it a set, you see how we have the curly brackets there? So that is the symbol we use for a set. Okay, so the first number is the x value, right, in the coordinate, or the independent variable, or the input. So we're using, okay, so we have here x value, input, so we have all of those. Remember, we also use the set of all inputs is called the domain. And then we have the y values for each order pair, and those are the outputs. 9, 13, 15, 15, 12, and 10. And I know that you can already see that one number is repeating, 15. But let's see if that makes our relation not be a function. And I want you to notice we already know it's a function, but let's see why. So in the definition, we have that each element of set A, in this case the time of the day, has to be related to exactly one element in the set B. So let's see this. Is 4 related to only one element in the temperature in set B, or the outputs? Yes, 4 is only related to 15. There we have it. Now, is 3 only related to one element from the other set? Yes, only 15. It just happens that the temperature at 3 p.m. and 4 p.m. was the same, 15 degrees Celsius. However, we're not saying that at 4 p.m. the temperature was 15, but it was also 20. We're not saying that. So because of that, this relation is a function. And we also have it here. It is a function. So repeating the values on the output, it's okay. The ones that cannot repeat will be the x values. So for example, the one I gave you, if we had that, this would have made the relation not be a function. And if you think about it, it's kind of like impossible to have two different temperatures at the same time, unless you consider like different countries or different parts of the city. Sometimes that happens. But if you are checking the temperature at the same exact place, then it has to give you only one reading and one reading only. Of course, if you want to think about Fahrenheit and Celsius, yeah, they will be different. But that's how we have to be careful and understand how the function is defined, or how you want to define your function so that it still makes sense and it meets the requirements. So the next box, it has a little bit of like kind of like a checklist, and is of course derived from the definition of the function. And the checklist has 4 points. So this is how you will check if a relation is a function. So at this point, I know we've been using both words, relation and function. So I want you to think of this. A relation is the big set. Relations. And here we have two types of relations. The ones that function, just like couples or friendships, and the ones that do not function. So all functions are also relations, okay? But not all relations are functions. Do you see that? So you could have a relation that is not a function. So for example, if we were to invert the order of these 2 points, and we will have something like 15 related to 3, and then 15 related to 4, then that will make it not a function, because 15 is being related to 3, but also to 4. So it's not related to exactly one element from the range or the second coordinate of the order pair. So that's what makes it not a function. So let's go over the numbers. Number 1 says, and here remember we're using set A as the domain, and we're going to use set B as the range. So each element in A, and the word each is so important too, because every single element from A needs to have a partner. So every single element must be matched with an element in B. So every single one has to have a partner. Now, number 2 says, some elements in B may not be matched. And that's still okay with the elements in A. So the ones that must have a partner, the elements from A. Now, number 3, 2 or more elements in A may be matched with the same element in B. That's kind of like our example with the temperature, this one. We have 2 different elements of set A being matched to the same element in B, which in this case is the 15. And that's still okay, meaning that the elements in B, they can repeat. And for number 4, we have that an element in A, which is from the domain, cannot be matched with 2 different elements in B. So that is actually the example that we're seeing here. That if we were to reverse which one is the set A and set B for the example with the temperatures, if we were to reverse the order of this relation, making the temperature being the set A, the dependent, and then the independent, and then making the time being the set B, then that wouldn't be a function like I was showing here. So I could give you some little shortcuts. So if you see that, let's make this number 5. X's cannot repeat. And number 6 will be that Y's may or may not repeat. So if you could check for that, that could be an easy way to check if you have a function. Of course, if you have X values repeating, but they are going to the same exact Y value, it's still okay. But if they're going to a different Y value like here, that is what makes it not a function. Now, can the Y values repeat? Yes, that is perfectly okay as long as it is the y values.